Okay, so let's say we want to find the distance and midpoint of these two points, right? Well, if I wanted to find the midpoint, midpoints are just the average of two, right? So don't overthink it. So like, if I wanted to find a simple average of two numbers, let's not overthink it. Let's say I want to find the average of a 2 and a 6. So what's the average of a 2 and a 6? Well, I would simply add those two numbers together and divide by 2, right? And that gives me the average of a 2 and a 6. So what is the average of 2 and a 6? Well, 2 plus 6 is 8. 8 divided by 2 is 4. Okay. That's all the midpoint really is saying. So the midpoint formula is simply saying I want the averages of my x's, right? And x1 comes from point 1, which gives me x1, y1. And then x2 comes from the x value of my second point, and then y2 comes from the y value of my second point, right? So again, x1 comes from point 1, y1 comes from point 1, x2 comes from point 2, y2 comes from point 2. I label everything thoroughly. If you find yourself plugging the wrong numbers into the wrong part of the functions or equations or whatever it is you're trying to do substitutions in, you might want to label everything thoroughly first and then do the substitution afterwards. Once you get the hang of it, obviously you don't have to do that, but in the beginning, again, you just don't want to make careless errors. So the average is, well, I would just add both these x values together and divide by 2, and that gives me the averages of the x. Well, what's the y's? Well, I'm simply going to add the y values together and divide by 2. And that will give me the average y value, right? So I'm going to plug everything in, but again, it looks like a much more complicated equation, or the pattern for the midpoint looks kind of scary, but it's really not. It's just the average of the x's and the average of the y's. That's all they're saying here, right? Okay, so the x's. Well, x1 is a 0, and I just got it right there, right? And then we have x2 is the 4. So 0 plus 4 divided by 2. Well, that's simply going to be 4 divided by 2, which gives me a 2, right? I know this is crooked. Sorry. Okay. Now, what about the y's? Well, the y is going to be y1, which is a negative 3, plus 1 over 2. A negative 3 plus 1 is a negative 2, so negative 2 over 2. And negative 2 divided by 2 is a negative 1. And there we go. Right? So the midpoint of those 2 points is the 2, negative 1. And that's all you're doing for the midpoint. So don't overthink midpoint. It's just the averages of the x and y's. Obviously, you could probably just do the simpler ones mentally. You just add the 2 x's together, divide by 2, that's my x. Add the 2 y's together, divide by 2, that's my y. And you got your midpoint. That's it. So that's not too bad. Now let's look at the distance formula. That's a little more complicated. So let's go to the Cartesian coordinate system or the rectangular coordinate system and just kind of look at something. So let's say I put a point right here, which is 1, 1. And let's say I put another point over here, which is, I guess, maybe 4, 3. I'm trying not to do all repeats, make it a little more complicated. Okay. Now, Cartesian coordinate system, let's say we drew kind of a vertical and horizontal lines through here, right? So let's say my vertical through that, vertical through that. I'm trying to make this solid, but it's not working out very well. Okay, so we got that. And then let's say we do the same thing, but now we do it with the verticals, right? All right, just kind of that. Okay, like that. Okay. And then let's say let's draw a line through these 2 points. And that's what we're trying to find. We're trying to find that black line, and we do have enough information to find the blue and the red we have there. Now, if you kind of look at what that makes, it makes a box with a line through the middle, or it makes a couple of triangles. Now, we actually know information about triangles. We know how to find parts of a triangle, right? So for instance, if you use the Pythagorean Theorem, we could say, for instance, this over here, we could have, this is the A, this is the B, this horizontal part there is the B, and we would say this part in the middle would be the C, which is the hypotenuse, okay? So basically, we could say the Pythagorean Theorem is A squared plus B squared is equal to C squared. And this is a relationship of the legs of a right triangle, it has to be right triangle, to the hypotenuse. This is, which is C squared, yeah. So A squared plus B squared is equal to C squared. Now, the hypotenuse is just solving for the C there. So we would just get that, and we would just take the square root of that. So basically, we're just solving for C, which gives us this right here. So it's c is equal to the square root of a squared plus b squared. That's how you would solve for the hypotenuse, right? Now, the distance formula is basically just saying is we need the additional step of finding out, well, what is A? What is the length of A? What is the length of B? Well, for instance, let's say we're trying to find A, which is this vertical part right here, right? The distance between there and there. Well, if I say the y value of 1 is 3 and the y value of the other one is 1, what's the difference between 3 and 1? Well, it's just 2, right? 3 minus, so we would say 3 minus 1 squared, right? And that just gives me the 2, right? Okay, well, what about B? Well, B is this, the horizontal part right here, right? And we would say, well, what is the difference between 1 and 4? What is the difference between 1 and 4? All right, well, what's the difference between 1 and 4? Well, between 1 and 4 is a 3, right? Okay. So 2 squared is a 4, 3 squared is a 9, and that would give you a 13. 4 plus 9 is 13, right? Okay, and we're still doing the C here, right? We actually got our answer here. This is not a nice answer, but that is an answer, right? All I'm really trying to point out here is that please don't overthink the distance formula. It's just the Pythagorean theorem solved for the hypotenuse. That's it. And with the additional step of, you have to solve for the length of your A leg and the length of your B leg. Right? They're going to make you do that additional step. So they just want to know the difference between the x values of your 2 points and the y values of your 2 points. Right? So the easier ones, you can really get the hang of this. Now I'm going to write the formula. It's going to look scary, but it's not that bad. It's not that bad. Okay, so let's see what the distance formula is. So instead of just writing a c, we're going to use d for distance. We're going to say the square root of. Instead of writing a there, which would be like the Pythagorean theorem had an a, we're going to say, well, we need to find the difference in the x's to get the horizontal leg. Then we need to get the differences in the y's to find the vertical leg, whatever that leg is. Right? And then once we find the difference, we square it, we add them together, and we take the square root, and that gives us the distance. Okay, now, I've already thoroughly labeled everything, so now we just plug it in. Now, even if you don't understand the whole thing about the Pythagorean theorem, how it's derived, and all you have to do is, even if you really don't get it, is algorithmically you just label all your points thoroughly, label all your x's and y's thoroughly, and then substitute in your variables into your distance equation and solve. So even if you don't really know what you're doing necessarily, you can still get the correct answer just by being very careful and plugging everything in. Okay, so at this point we just plug everything in. So what is x2? Well, x2 is over here, it's the 4. So I plug in the 4. Minus, what's x1? x1 is the 0. I plug in the 0, square it, plus, what's y2? y2 is the 1. I've already labeled it. What's y1? y1 is the negative 3. Negative 3. So I'm saying minus 3. And then once we get that, we square it. Okay, so let's do some simplification. 4 minus 0 is 4, and then 4 squared is 16. We would say 1 minus negative 3 is the same as 1 plus 3, which is a 4, and then it's going to be 4 squared, which gives me another 16. And then once we get there, we're going to add these together. All right, we're going to take the square root of this whole thing. And that gives me the square root of 32. Square root of 32. Okay, and that is equal to d. Hopefully my handwriting is not too bad. Okay, now as far as radicals go, we are kind of expected to simplify this. So we have to simplify this. So a couple of ways of doing it. One is you can factor out the largest perfect square. And perfect squares would be things like, 1 squared is 1. That's not helpful. 2 squared is 4. That is a 4, not a 9. 3 squared is 9. 4 squared is 16. So on and so forth. So the largest one that we can factor out is, in fact, the 16. So we factor out the 16. All right, so we say, well, 16 times 2. Then what we do is we pull this apart. So we say square root of 16 times the square root of 2. Then we take the square root of 16 is 4, and that leaves me the square root of 2. So that's one way to simplify it. Another way of doing it is use the prime factorization of 32, which is 2 times 2 times 2 times 2 times 2. And because there's understood 2 index there, you don't see anything, then we're simply going to take out a couple of groups of these 2's, and whenever we pull it on the outside, we only write it down once. So we say 2 times 2 times, and because this 2 is left over, the rest in a pair, we leave it underneath there, and 2 times 2 on the outside, you multiply those together, gives you a 4. Anything left on the inside, in fact, this case, there's only a 2. There's nothing else but the 2. So you leave that on the inside, and you get exactly the same answer. So either way, you end up with 4 square roots of 2. All right, not too bad. Let's double check, make sure we answer the question. Find the distance, check, 4 square roots of 2, and the midpoint, check, to -1. That's the midpoint. Okay, so give the center and radius of the circle for the given equation of parenthesis x minus 1 in parentheses squared plus parenthesis y plus 3 in parentheses squared equals 144. General equation of a circle that we're going to be dealing with now is going to be something like x minus h squared plus y minus k squared is equal to r squared, where the center, where's the center? The center given this pattern is going to be something like h k. And that'll make sense hopefully in a second. That's the center. Okay. Now, they want the center. Well, how do we interpret it? Well, we just basically flip the signs, right? Notice that it's a negative h and a negative k here. It kind of reminds me of the parabola. Whenever you had the x in parentheses, that it had the opposite looking effect. And this also has the opposite looking effect. So the center on this one is not going to be, it's not going to be a negative one. It's going to be a positive one for the x values. And it's not going to be a positive 3. It's going to flip, and it's going to be a negative 3 for the center. So that's actually the center on this one. So that part was pretty easy. Center. Okay. Now they also want to know the radius. The radius. Well, what we do know is that r squared is equal to 144, right? Just like here, the r squared. Okay, because this is already solved. It's already in this proper form. If it wasn't in this form, it would be a little more complicated. But since this was already in the kind of almost a standardized form, it makes the interpretation much easier. So we do know that whatever r squared, which is the radius, the r squared is equal to 144. And then how do you find that? Well, we're only interested in the positive one, so in this case, the notation is actually correct. But if I take the square root of both sides, undoes the r squared, gives me an r, gives me the positive version of this, right? And the square root of 144 is a 12. So in this case, I know that the radius of the circle must be a 12, and the center of this circle must be a positive 1, negative 3, the opposites of the numbers that are manipulating the x's and the y's within those parentheses. So